Alrighty, so part A, we need to find the values of the two unknowns here, M0 and K. Now I've got some radioactive substance that is decaying, so it's getting smaller and smaller in size, and the relationship for this decay is given by this here. So the mass of the radioactive substance is given by capital M, and it's decreasing at this rate here, e to the minus kt. Alright, so let's find M0 and K. Now we know that at time 0, the mass is equal to 10. So let's sub in t is equal to 0. Now this will be 0 up here because k times 0 is 0, and e to the 0 is just 1. And we also know that at t equals 0, the mass is equal to 10 grams. So we know this is also equal to 10 grams. Great, so we've got our equation now. Got 10 out the front, e to the minus kt. So now let's use the second bit of information we have to find k. Because remember, in general, if there's two variables we need to find, we need two sets of information. So we've got our first set of information here and our second set here. So this was to find M0 and this was to find K. So when t is equal to 140, we'll sub in t is 140, and we'll get 10 e to the minus 140 k. And we know that the mass will equal 5 here. And then we'll divide both sides by 10. So we'll get e to the minus 140k. Because remember, we're trying to isolate this k, so we need to kind of reduce the expression a little bit. And then let's use our index laws. So if we have log to the base a, b is equal to x, that's the equivalent as saying b is equal to a to the x. So we can use this relationship here. So we've got our a, then we've got our b, and last but not least, we've got our x. Alright, so we can say that this is equivalent to log to the base e 1/2. And we know that's going to be equal to minus 140k. And then what we need to do is we need to get k by itself. So let's just divide both sides by 140. So we'll get k is equal to minus 1 on 140 log to the base e 1 on 2. Now you can either chuck that straight into your calculator or you can simplify it a little bit. You should also note that, well, 1/2 is actually just 2 to the minus 1. So you can then use your log laws to bring minus 1 out the front, which will give you 1 on 140 log to the base e 2. Now you could have just chucked it into your calculator here, but it's always nice to make things look a little bit nicer. And once you do chuck it into your calculator, you'll end up getting about 0.00495, which is, I should be writing the approximate one here, not here, which is equal to 4.95 times 10 to the negative 3 in scientific notation. Now part B, what will the mass be of the element after 70 days? So to do that, we just want to sub in T is equal to 70. So we go the mass at 70 days is equal to 10e to our K, which we have up above. Is it minus K? I think it was minus KT. Yep. Now I'm not going to write K down there because it's just a bit annoying and cumbersome, but remember that K is equal to this. Any of those three. And what we can do is actually, no, we can write it down. It won't be too bad. They've made the question nice for us. We'll write this form down here. So we've got minus 1 on 140 log to E2 and then times by 70. So they've been quite nice to us. So the 70 over 140 will become a half. Great. And what we can do with that is we can chuck it into our calculator now, and we'll get something that's approximately 7.0711. So that'll be its mass after 70 days. Alright, now we can look at question C. Because we want to find after how many days is the mass remaining 2 grams. So we're going to try and find T here. So when at what T is M equal to 2? Alright, so we'll put the mass is 2 grams on the left hand side, and then we know that we've got this relationship up here. Now the one thing we want to find now is we want to find T. Remember, we still know what K is because K we found in part A. So we'll divide both sides by 10, which will give us 1 on 5 on the left, and we'll get minus KT on the right. And then we can use the same index law as we used above, and we'll get minus KT is equal to log to the base E 1 on 5. And then we'll get T, because we'll divide by minus K on both sides. We get T is equal to 1 on minus K, log to the base E 1 on 5. Now, that'll end up giving us minus 140 if we actually sub in K, log E 1 on 5 over log E divided by 2. Chuck it in your calculator now, and that'll give you 325 and about 0.7. So what that's saying is, after 325 days, the mass remaining is 2 grams. I should say approximately here as well.